Hello. In this video, we're going to continue our study of transformations. And let's take a giant transformation. Y equals negative 3f, bracket negative 1/2, bracket x plus 2, close brackets, minus 4. What does each number represent as a transformation? So let's go through these one at a time. The negative 3 represents a vertical stretch by a factor of 3 and a vertical reflection. The negative 1/2 represents a horizontal stretch by a factor of, remember we have to flip it, 2, and because it's negative, a horizontal reflection. The plus 2 represents a horizontal translation of 2 units, and remember because it's plus we have to go the opposite direction, so 2 units left. And the minus 4 represents a vertical translation of 4 units down. All right, so we have our 4 numbers, and they represent 6 different transformations. A vertical stretch, vertical reflection, horizontal stretch, horizontal reflection, horizontal translation, and vertical translation. We could also represent this as a mapping, so xy is going to become, well, we're going to do the multiplication first, so 2 times x, and then we do the horizontal translation, so we're going to subtract 2. Then for the y values, we have a negative 3 times the y, and then we're going to subtract 4. So remember, we have to do the stretches and reflections first, in other words, the multiplication first, and then we do the translations last. So here we have the negative 3 is for the y, and the negative 4 is also for the y, with the negative 3 happening first, and then the subtraction happening second. Here we have the negative 1/2 becomes 2. Oh, lost that negative 2. And then the plus 2 becomes a minus 2. All right, so there's all of our transformations, either written as a transformation equation, written out in English, or written as a map. Now let's go ahead and apply these transformations. So here we have a little graph. It's like a W shape. These are the points, and we want to apply these transformations. So go ahead and pause the video and apply these 6 transformations. All right, assuming you gave it a try, let me go ahead and start with our initial table here. So we're going to have x and y. We got 0, 2, 1, 1, 2, 2, 3, 1, and 4, 2. And that's going to make a new table. This is our old one. This is our new table. So for the x values, again, we have to multiply by negative 2, and then we have to subtract 2. So 0 times negative 2 is still 0. Then we get minus 2. This is going to give me 1 times negative 2, so negative 2, and then minus 2 is negative 4. 2 times negative 2 is negative 4, minus 2 is negative 6, negative 8, and negative 10. For the y values, 2 times negative 3 is negative 6, and then subtract 4 is negative 10. 1 times negative 3 is negative 3, minus 4 is negative 7. This will be another negative 10, negative 7, and negative 10. Now we're going to take those points and put them on a graph. So we could go left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 2 and negative 10. Negative 4 and negative 7. Negative 6 and negative 10. Negative 8 and negative 7. And negative 10, negative 10. Now, because there were initial arrows, we would want to extend the graph like this. And there's our nice transformed graph. Okay, what I want to do now is go the other way. I want us to start with a graph. So the blue graph is going to be our initial f of x. And the green graph is going to be our y equals some kind of transformation. Now, we can tell that obviously they're not the same graph because, well, the green graph is not the same as the blue graph. But of course, they have been transformed somehow. We can see there's some connection between the green and blue graph. And the question is, what's the connection? What's the transformation? How did the blue graph become the green graph? So the first thing we might notice is that the green graph is a little bit larger. The initial blue graph, the triangle that we had here, had a base of 2 and a height of 1. Now over here, this graph has still a base of 2, but a height of 3. So it looks like it's been stretched vertically. Not horizontally, it's the same spacing horizontally, but vertically it looks like it's been stretched by a factor of 3. So I think we have a vertical stretch by a factor of 3. And it looks like it's upside down, so I'm thinking that's a 3 minus. Now let's keep trying to figure out what that would do. If we took our initial graph and we made it a vertical stretch of 3, that would make it go up to here, right? Something like that. And if we flipped it down, well, that would make it way down here, something down there. And yeah, maybe like this. And that's not going to do for us because we need the graph up here. Well, I think that means there's going to be some kind of translation. And it's nice to look at, for example, this point here, 0, 0, because it's not affected by the stretches. But it will be affected by the translations. It's not affected by stretches because it's 0, so when you multiply, it's still 0. So let's imagine this point, and I think it's supposed to move over to this point. Notice how it's at the beginning there of the triangle, or the W. So this point has moved over there, and that means it's moved over 1, 2 to the right, 1, 2, 3, 4 up. In other words, I think we have a vertical translation of +4, and we have a horizontal translation of +2. So let's put all that together in our transformation equation. Minus 3f x minus 2. Remember, if we want to move it to the right, we have to put a minus. And then plus 4. So that would indeed be our transformation equation. And if we wanted to confirm, we could try another point or two. So for example, let's try the very top of the little w. This point initially is 1, 1, and it becomes 3, 1. Now, if that's correct, if our transformation equation is correct, we should be able to apply these transformations and go from 1, 1 to 3, 1. Well, let's give it a try. The point for the x, here's our x and y, our old ones, and our new ones. The x should have 2 added to it, so 1 plus 2 equals 3. And the y we should multiply by -3 and add 4. So 1 times -3 plus 4 is going to be -3 plus 4, which is 1. So our new point is 3 and 1, which is exactly what we have here. So I want you to give this a try. The initial graph here is in black, and this is the new y equals graph. There's been some kind of transformation. I'd like you to pause the video and see if you can determine the transformation. All right, assuming you gave that a try, we want to focus on that little triangle. That's a good shape to track. We notice that it's got the same height over here, but the base is twice as large. So I think in our transformation equation, we're going to have ourselves a 1/2, which will stretch it horizontally by a factor of 2. Now, I don't think there's any reflections, but I do think the graph has been moved. It looks like the graph here has moved to the left 6 and down 1. If we track this point over to here. So I'm thinking we should write x plus 6 to move it left 6 and then down 1. Then if we wanted to give that a test, we could just pick a point on the graph. Maybe you could pick this point right here, 1, 1, and confirm that it ends up at -4 and 0. So again, we could take our 1, 1 and apply our transformations. So we have to take the x value and multiply by 2. So 1 times 2 and then subtract 6. The y value, we have to subtract 1 from it. In other words, 1 times 2 minus 6 is -4. 1 minus 1 is 0. There we go. It checks out. All right, let's do another one. Here we have the initial graph again in blue. And we're looking for a y equals in green. So pause the video and give that a try. All right, so again, if we focus in on that little triangle shape, I think it's the same height, but it looks half as long. It used to be 2 units long, now it's only 1. So we're definitely thinking that there should be some kind of horizontal stretch. Looks like a 2 to make it 1/2. Then we can track that point on the origin. It used to be at 0, 0. Now it looks up over at -1 and 3. So I'm thinking we should go 1 left and then up 3. However, there's one other thing to keep in mind. The initial W looks like it's facing up, but this looks like it's pointing down. So I think we also need to add a negative for that vertical reflection. Again, if we wanted to confirm, we could take maybe that point on the very top here, 1, 1, and that's going to become -1/2 and 2. So if we take the point 1, 1 and apply the transformations, first we have to take the x value and multiply it by 1/2, then subtract 1. For the y value, we have to multiply by -1, and then add 3. So that's going to give us 1/2 minus 1, which is -1/2, -1 plus 3, which is 2. So that checks out. All right, here's one more for you to try. Again, we have the initial graph here, and we're looking for some transformation equation for the green graph. So pause the video and give it a try. All right, so assuming you gave it a try, you should end up with -1/2 f 1/2 x plus 5. So there's been a vertical reflection. The little triangle is half as tall, so that's why we got a 1/2 there. It's twice as wide, so that's why we have a 1/2 here to do a horizontal stretch by a factor of 2. And then this point has been moved up 5. Combining all those transformations, we read it like this. And of course, we could check a point if we wanted to, but this is indeed the correct answer. So let's go ahead and take some notes on this. We are, again, working with all the transformations. So working with transformations. And again, if we have y equals a f b x minus h plus k, one thing you might want to write down is the general mapping equation. So xy becomes 1 over b x plus h ay plus k. That's another way to think about it. We can take the initial xy point and we can map it onto this new point. And this is important because sometimes we have to check points or we have to figure out how one graph gave the other graph. So again, I'll give you a little sample graph here. So the original graph will have points at, let's do 1 and 0, 2 and 1, and 3 and 1. So here's your initial graph. No arrows on it, it's just a little like ramp shape. And then your new graph is going to be at -1 and 3, -2 and 5, and -3 and 5. So again, I'll put these in a little table. So the initial graph is at 1, 0, 2, 1, 3, 1. And the new graph over here is at -1, 3, -2, 5, and -3, 5. And you have to determine the equation y equals something as our transformation equation. So go ahead and pause the video and give it a try. All right, now there's going to be a horizontal reflection. So we definitely have to put a -x there, but there's no horizontal stretch because it's the same width. It is taller, so we're going to put a 2 here, and it looks like it's been moved up 3. All right, if you need some more practice on this, I definitely would encourage you to add another example here to your notes from worksheet 10 or 10.5. You can also practice the questions on there. And then you can write down any things to remember. All right, hopefully you enjoyed this video. And as always, thanks for watching.